Hello, this podcast is about energy. We can think of energy as a substance-like quantity that can cause change. That's important to know. No change can occur without energy. Energy makes objects move, makes things stop. It's needed to do work. But while we can think of it like a substance, it does not have mass or volume. And the SI unit for energy is joule, named after a famous scientist. But in base units, the energy is kilograms meters squared per second squared. But again, we can use the special symbol joule. Energy is stored in objects using one or more storage mechanisms. So energy flows from one storage mechanism to another storage mechanism within the same object, and it can flow from one object to another. In these pictures below, we can see with the hot cup of coffee, the energy is flowing out of the cup of coffee into its surroundings. On the other hand, if we have a cold can of soda, we can see that the energy from the warmer air is being flowed into the soda in the can. Let's talk about the storage mechanisms. These are ways in which energy is stored in objects. You can think of them as buckets, separate buckets that hold energy within an object. There are 6 of them for storing energy: gravitational potential energy, elastic potential energy, chemical potential energy, kinetic energy, thermal energy, and dissipated energy. First, let's talk about the broad category called potential energy. Many physics textbooks group gravitational, elastic, and chemical potential storage mechanisms into potential energy. They do not distinguish between these types of potential energies. However, in this course, we are going to use the 3 specific potential energy mechanisms: the gravitational potential energy, the elastic potential energy, and the chemical potential energy. Let's take a closer look at each one of these mechanisms. Gravitational potential energy is the energy stored in an object that is positioned above another larger object that exerts a gravitational pull on it. For example, a boulder positioned above the Earth has the potential to fall to the Earth. A roller coaster at the top of a hill has the potential to go to the bottom of the hill, and water stored in a reservoir above a turbine has the potential to flow through that turbine and create electricity, as is done in hydroelectric dams. The amount of energy stored in this gravitational potential mechanism increases as the object gets further and further away from the source of gravitational pull. For instance, the further this boulder gets from the surface of the Earth, the more gravitational potential energy that is stored in it. Let's move on. We have elastic potential energy, and this is stored in an object that is temporarily compressed or stretched. And the amount of energy stored in that mechanism increases the more the shape is compressed or stretched. Now, I want to stress that this temporary situation is important. For example, the twisted rubber band in a toy airplane has the potential to unwind and move the propellers of the plane. An archer's bow can be drawn back, and energy is stored in that compressed shape of the bow, which has the potential to launch the arrow. Finally, a stretched bungee cord has the potential to move back to its original shape and perform work. Now, if something is stretched or compressed and it won't come back to its original shape, that does not hold elastic potential energy. As an example, if we stretch a spring so far and so hard that it just stays permanently stretched, there's no energy stored in that. Let's move on and look at the third type of energy that falls under the broad category of potential energy, and that is chemical potential energy. And that is the energy stored in the chemical bonds of the molecules and the attractive forces between the molecules. Examples of this is coal burned in a power generating plant. So the energy in the bonds of the coal store energy that's released when the coal's burned. Steam created in a power generating plant has the potential to flow through turbine blades and generate electricity. Finally, the chemicals that make up the anode and cathode of a battery have the potential to create electricity. So let's move on and do a learning check. What are the three mechanisms for storing potential energy? Pause the video now and see if you can come up with them. Ready to check your answers? Did you get them all right? We're now going to move on to energy storage mechanisms that are not potential energy mechanisms. So the first one is kinetic energy, and it's the energy stored in the purposeful movement of an object. The amount of energy stored in this mechanism increases as the speed of the object increases. Some examples of energy being stored in the motion of an object is a boulder falling off a cliff to the earth below, a roller coaster going down the tracks, and water moving past a turbine blade. And let's just take a moment and think about this and potential energy. In a previous slide, we gave the example of storing energy in the gravitational potential mechanism as a boulder on a cliff above the surface of the Earth. And the reason we called that potential energy is it wasn't doing any work at the moment, but it did have the ability or potential to do work if the boulder would fall to the ground. Same thing with the roller coaster. If it's at the top of a hill, just sitting there motionlessly, it's not doing any work, but it has the potential to go down the hill, and then it would do work, in this case causing the object to move, which then transfers the energy from the gravitational potential mechanism into the kinetic mechanism. But we'll get to how energy is transferred in a couple minutes. Let's move on to another type of storage mechanism called thermal energy, and it is recoverable energy stored in the random motion of particles. And when I say particles, I mean atoms and molecules. So examples of this would be the random motion of hot gas particles going up a fireplace chimney, the random motion of the atoms in the metal heating elements of a toaster, and the vibrating motion of the particles that make up ice. Yes, even cold objects have thermal energy. Let's learn about our last storage mechanism, dissipated energy. And this is the unrecoverable energy stored in the random motion of the particles. Now, I want to contrast that with thermal energy. That's energy stored in the random motion of particles, but it can be recovered for useful purposes. Dissipated energy, while it's also stored in the random motion of particles, it's not energy that's able to be recovered to do anything useful. So examples are the brakes heating up as a car is slowing down. That energy that causes the temperature of the brakes to increase, it's storing energy, but it's not any energy that is useful or can be recovered to do something else. So we call it dissipated energy. The sound created when I clapped my hands has energy stored in it, but this energy is not able to be used for anything purposeful. So again, it's considered dissipated energy. So friction causes energy to be stored in this dissipated mechanism. The energy spreads throughout the system and or its surroundings and cannot be harnessed for useful purposes. Important to note, dissipated energy is not lost energy, but it is unrecoverable energy. Let's take another learning check. What are the three storage mechanisms that do not fall under the broad category of potential energy? Pause the video and see if you can come up with these three storage mechanisms. Let's see if you got them. Kinetic energy, thermal energy, and dissipated energy. Now we're going to move away from storage mechanisms and we're going to talk about energy transfer mechanisms. So energy can be transferred from one type of storage mechanism to another type of storage mechanism within the same object, or energy can be transferred from one object to another. And this can be transferred by one of three ways, and these are known as transfer mechanisms. We have working, which is also known as work. We have heating, also known as heat, and we have radiating, which is also known as radiation. Let's take a closer look. Working transfers energy when an object moves parallel to a net force. So examples would be an electric motor is working, that is, performs work, when it lifts a roller coaster cart to the top of the hill. This transfers energy from the motor to energy stored in the gravitational potential mechanism of the cart. Another example would be a person is working when they throw a ball in the air. This transfers the kinetic energy stored in the person's hand to the energy stored in the ball's kinetic and gravitational potential mechanisms. Moving on, let's look at radiating, also known as radiation. This transfers energy between objects or systems by the emission and absorption of electromagnetic radiation, also known as photons. For example, when you feel the sun's warmth on your face, the sun is radiating energy by emitting photons that travel 93 million miles before being absorbed by your skin. When you heat something up in a microwave oven, the microwave is transferring energy by emitting photons that are absorbed by the food. Let's take a look at our last transfer mechanism, heating, also known as heat. The heating mechanism transfers thermal energy or chemical potential energy stored in one object to thermal energy or potential energy stored in another object. For example, when you use the stove to boil a pot of water, heating is transferring the thermal energy stored in the hot burner to energy that is stored in the water as thermal energy and chemical potential energy. Another example is when you use a hairdryer to dry your hair. Heating is transferring energy from the hot air of the hairdryer to the moisture in your hair. Finally, there's two ways heating can occur, either through direct contact, which is called conduction, or through contact with an intermediary medium like a liquid or gas, known as convection. Let's do one more learning check. Here are 4 questions. Pause your video now and see if you can answer these. Let's see how you did. Let's wrap up this video with a summary of what we've learned. Energy is a substance-like quantity that is stored in physical systems, and it can flow between the storage mechanisms within a system, or it can flow between a system and its surroundings, or it can flow between 2 different systems. Energy is stored in a system or object in 6 storage mechanisms: gravitational potential, elastic potential, chemical potential, kinetic, thermal, or dissipated. And finally, energy flows between systems or objects through transfer mechanisms. There are 3 of them: working, heating, and radiating. I hope this podcast gave you a better understanding of how energy is stored in objects and how it flows between objects and their surroundings. Have a good day.